Hello, 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 Internet. It's Clint again, back with another Ziti TV. It's a Friday. It's been a minute since we've had one of these, and so it's time to have another. This week's ZD TV is going to be demystifying zero trust. So, on the forum, we had somebody pop in and say, "Hey, Doc is cool and all, but it would be great if you could just give me the basics for while I get started." And I said, "That's a really good idea. We should go through and do that." Now, we have done that before, and we do that every now and again, but I think it is always useful to revisit the idea of what exactly it means to be zero trust. Uh, is it complex? Is it crazy? Is it as hard as everybody makes it out to be? Is it overkill? That sort of thing. So that's what we're going to look at today. If you are not aware of it, my buddy Philip, actually, let's read the release notes first. We oftentimes will do this, and so you can see a lot of pre-releases are coming out nowadays. These pre-releases are HA controller pre-releases because we've been working really hard on getting that HA controller functionality out the door. And so when you see these pre-releases, you'll know what they're all about. Um, this one right here has a bunch of updates for bugs. Let's see. How about if I shrink it down to about this size? That seems legible. I know that I was working with Andrew a fair bit. We were working through some external JWT signers stuff, and I think maybe next week will be a ZDTV where I take a look at ZSSH again, because last year Paul Otto had a great pull request that added external JWT signers to JWTs. Sorry, to ZSSH, and I think that'll be a fun and exciting ZDTV. So we'll do that. I think maybe next week, maybe the week after. But along those ways, I found a few bugs that needed to get fixed in our pre-releases, and so Andrew fixed those. So that's what you see here. A fair bit of uh, OIDC slash JWT type related stuff, just random bug fixing that's going on as we keep testing and harden that HA controller release. As I was saying before, though, if you have never found Philip's blog, and I don't know how you couldn't because he plasters it all over the internet. Good for him. Um, there's a great blog that he wrote that kind of talks about things from a even higher level than what I'll talk about today. I'll make sure that this gets into the show notes so that you don't have to go transcribe that, but you can just Google demystifying zero trust OpenZiti and it'll bring you right here. Um, anyway, it's a really nice little preface for what we're going to be talking about today, which is basically, the whole idea of non-magical zero trust, where um, basically one of the core tenets of an OpenZiti protected service is that your service actually is not exposed directly to anything other than the overlay network itself. So we'll get into that because that's really part of I think for me, that is part of the actual magic of OpenZiti, the idea of no listening ports. And so speaking of that, I'll make sure this also gets in there too, which is no listening ports. This blog post I wrote. Um, and this is all about that sort of magic of no listening ports. And so if you haven't gone through and read this one, this is also a good one. And here's where we're going to start because it has some of these nice graphics. So generally speaking, and if I look over here, it's because I have another computer, so I'm not going to look at you for a little bit, or not another computer, but another screen. So generally speaking, when you stand up some server somewhere in some cloud vendor, the thing that you need to do first is you need to open a hole in the firewall. You have to provide access to the rest of the world or to a small subset of the world to that machine out in the cloud somewhere. Oftentimes it's a single IP address, right? So what I will do when I start for example, let's take OpenZiti. OpenZiti has two necessities. One, you need a controller. Two, you need a router. Let's even start with what is a router and what is a controller. Let's go back all the way to the basics. We'll go to the documentation website and we'll look at what an overlay network even means. So here's an overlay network, right? You build on top of the internet a bunch of equipment like an edge router and a controller, and you put them into the internet and you expose those things to the actual internet. But you don't just expose them willy-nilly, you expose them with secure connectivity between everything. So zero trust, a fundamental. Oh, by the way, ask any questions. This is we have a chat, so if chats come in, I can ask questions along the way or answer questions along the way. And so a fundamental tenet of zero trust is this notion of a strong identity. You must have a way of verifying who is connecting to your network. The whole notion of zero trust is about not trusting implicitly any connection. It's about trusting explicitly every connection. And so what that means is instead of allowing anonymous connectivity, you must verify and validate and authorize every piece of connectivity to your server. And so to do that, you build an overlay network. In this case, OpenZiti is composed of edge routers. These edge routers, we do have things called fabric routers. Generally speaking, not necessary until you start doing more advanced stuff with OpenZiti, like trying to make a custom path through your infrastructure. But the idea of a core router or a fabric router would be one that doesn't service the edge. And so we have these things we call edge endpoints or SDKs or tunnelers. And their job in life is to connect to an edge router and provide that secure connectivity. All right. And so that's what an overlay network is at its most basic. We have a controller. Its job in life is to decide if you're authenticated and then if you're authorized to make a connection somewhere else. All right. So that's the basics of an overlay network. Let's go back now to when I stand up a computer in the internet. And the first one, or a server in the internet, and the first one I oftentimes will stand up is actually my OpenZiti overlay network. And so the first thing I had to do is I have to make that hole in the firewall. Now, making that hole in the firewall is usually, like I was saying, based around an IP address. What we want to do is we want to eliminate IP addresses from our networking entirely. We want to use that strong identity, that cryptographically verifiable document, in order to control that access. Now, with OpenZiti, and because the world is built on IP itself, in fact, that's part of the things that you'll see in here. Built, yeah. The world's built on TCP, on IP. And so because of that, you're still going to have a port somewhere open, because to get to from your house to the OpenZiti network, the overlay network itself, you're going to have IP somewhere. Or for your mesh to be formed between these routers, so router 1 talking to router 2 here, or anything in between, they'll all be connecting via TCP or IP. And so because of that, there will be ports opened. And one of the constant things that people on the internet will say is, you've removed my port from exposed from being exposed from the internet. That's great. But there's still a port that's exposed to the internet. And that is absolutely true. You'll never get away from that regardless. There are lots of ways that you can go about making that connection much, much stronger, though, one of which is mutual TLS. Mutual TLS is another term where we talk about having strong identities and verifying both sides of the connection. Every day we pick up our phone, you come to YouTube, and you start watching some guy blather on about demystifying zero trust, talking about servers. When you connected to YouTube, you absolutely connected using TLS. So that's a one-way verification. Your browser checked to make sure that the website you were going to, youtube.com. I don't even know if it's a .com. youtube.com. Your browser checks this this URL that you're accessing and says your connection is secure. And it does that by going through and looking at something called a trust store that's on your local computer that has all of the certificate authorities that your operating system trusts. Every operating system ships, maybe not every, but the one that you're likely using ships with a trust store that has a bunch of uh, pre-trusted certificate authorities. So you can go in and look at the certificates that your operating system trusts. If we look at this certificate, we can see that it comes from, let's see, where's the issuer? Go to the details. It comes from google.com, which has an intermediate CA of WR2. I don't know who they're from, and a root CA of GTS root 1. And I don't know if, well, let me see the certificate. Oh, right here. Here's the certificate. Here's the issuer, which is Google Trust Services LLC. So apparently, Google is its own root CA. Good to know. I actually never knew that because I've never bothered to inspect it. But all these CAs get together and they trust one another, and then the operating systems say, okay, these CAs are good to go. We can put them all in one big bundle and ship them down with your operating system like Windows does for me. So that's what single or normal TLS is all about. Mutual TLS takes that one step further, where when my browser connects to that server, my browser also has to provide a certificate, and that is one of the fundamental core tenets of zero trust. That strong identity, verifying that identity. Mutual TLS is a really important aspect of zero trust. And if you're not using mutual TLS, then you must be doing some other mechanism that is cryptographically verifiable. That's really the most important bit when it comes down to what is zero trust. After having a identity that is authenticated, the next sort of thing that you would do is you would verify that that identity is allowed to do something. When you first start with OpenZiti, you will have identities and they will be authorized to do nothing. And so you have to authorize them. And so let's step now into an overlay network, into an OpenZiti overlay network, where we have a few routers deployed. We have a browser trying to connect to some server, and it's going to be going over OpenZiti. In this case, we have to have a server that is allowed to bind a service. And so what happens is the overlay network needs to be told this server is actually an endpoint on the overlay network. It's the same thing as turning on a regular underlay. So you'll hear me say underlay, overlay a lot. Underlay, meaning the IP-based network. Overlay, meaning the OpenZiti overlay network that rides on top of IP, because again, we're not going to be getting rid of IP probably anytime soon. Who knows? Maybe someday you can come back to this YouTube video and comment about how silly that comment was, because whatever the next big thing is has been released. So we have to authorize that server to be able to bind a service on the overlay network. When you do it on the underlay network, it's still the same idea. You still bind an IP address and a port, but you're asking the operating system to bind that IP address and to bind that port. And so instead of asking the overlay network to bind a service, we'll call it a service because there's no port, there's no IP. Instead of asking the operating system that says, hey, I want to put a web server, I need to put it on 127.0.0.1, port 80. Instead of asking the underlay or the operating system, you ask the overlay, and the overlay tells you whether you're able to bind or not. See, the first thing you need to do when you want to start a server is you'll have to bind that server to the overlay. And so you'll have to authorize an identity to bind a particular service. The same goes for dialing or connecting to that server. You're going to have to authorize all of your clients to connect to that particular server. And that is a zero trust principle called least privilege. So with least privilege, as it sounds, you want to make sure that all of the identities have only access to the barest of essentials, whatever they absolutely need to have access to, and nothing more. You don't want to be giving your identities access to everything. You want to implement the principle of least privilege. All right, once you've got your principle of least privilege implemented, you now have a server. That server is permitted and allowed to bind to the OpenZiti overlay network. You have a client, and that client is allowed to dial or connect to that server. The next thing you need to do is you need to authorize these things. Actually, you've already authorized them. You need to, you can just connect them. I think that's it. That's really all there is to it. Now that I'm thinking about it. Yeah, you have to make a configuration, and that configuration talks about the way that things connect, and we'll get into that in a second because that's special to tunnelers and zero trust host access. But that's really, I mean, that's really it. After that, there's another principle of zero trust that is relatively important, at least to me and to us here at OpenZiti. You know what? Maybe I can bring up this presentation I just gave recently because boop, it has a nice little graphic on it and looks like this. And the next one is continuous authorization. So the idea of continuous authorization is once you have authorized your bind and your dial endpoints, the next thing you might want to do is you might want to make sure if anything changes that the connection, the dial connection is severed or the server connection is severed. So for example, a good example of that would be OpenZiti has these things called policies. Oh, great. We got a nice comment. Let's see. Oh, open source system says, great info and such amazing tech. Awesome. Thank you very much. Let's see. How do I put that? Ask questions or give me props. Give us props. We always like our props. Take our flowers. Okay. So I was saying continuous authorization. You might want to make sure that, say, a virus scanner is running. So you will check to see if a process is running, or you may want to make sure that the MAC address on the interface is the right MAC address for whatever reason, or that they're joined to the Active Directory domain, or whatever that posture is. You want to be able to do continuous authorization. On top of that, if you were to eliminate connectivity at the central controller, you want that connectivity to disappear immediately as well. Let's see if there's anything else that's interesting about zero trust from that presentation I gave. I don't think there is. I think that's it. So what we were talking about before is these three. Let's see. Turn it off and turn it on again. Come on, PowerPoint. You can do it. No, you don't want to do it. There you go. All right, fine. I'll have to do it this way. Let's see. Select slide. How do I do that on you, PowerPoint? Nope. We'll just click the button. Click, 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 click. And click, 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 click. Here we are. All right. So this is the next interesting slide, I thought, which is the three types of zero trust that there are. The first type of zero trust you'll find that I would say most people out there are considering zero trust is the top one, zero trust networking access. You install some sort of router in your trust zone, and then you trust everything in that trusted network, which doesn't sound very zero trust, does it? That's why I do kind of scoff at zero trust networking access. Let's go through the build. Maybe you've seen these presentations, you've seen it before, but here's your trusted zone. If you are using router to router based communication, you're trusting everything that sits on the other side of that router, and that could be something very tiny. It could be, could be just the host, but it also could be an entire network that's back there. A lot of times when you see us create configurations that define either offload or onload endpoints when they're not native to OpenZiti, you'll see us use 127.0.0.1 or localhost or ::1, something along the lines that is not routable over your general network. And that's very much on purpose, because a better way to do things is to eliminate traversing your trusted network and instead go directly to zero trust host access. This is what you'll see. Let's see, go to the next one where we have all these firewalls. So here you see we have two firewalls on both sides. We have the firewall that gets you into the trusted network, and then we have the operating system's firewall. So basically, this takes the idea of micro-segmentation. Another core concept of zero trust is segmenting your network down to the lowest form it can possibly be. And if you're at the host layer, that's pretty good segmentation, right? Like you've eliminated most of the threats entirely, because you're now only vulnerable to things that are sitting on your, where's my pointer? On your host device on either side. And so you're now susceptible to side channel attacks, but they're limited just to that machine and whatever that machine can reach out to. So to go back to that privilege or to that concept of least privilege, if your device has access to a single service, then any side channel attacks would only have access to a single service. That is very different than how VPNs work. VPNs, you are once you're on the VPN, you can get to is you can attack anything that's on that VPN, and even with zero trust network access, you would be able to access everything within that zero trust network access zone. So with host access, you have eliminated a tremendous amount of potential attackers, and you'll know that the exact identity, which is ending up, being compromised or actually attacking your overlay network itself. So zero trust host access is pretty good stuff. And you'll see this is OpenZiti has two different ways of doing this, either with ZT Edge Tunnel, which is what runs behind all of our desktop edge software. So if you go and you find the desktop edge for Windows, like the one I have right here, or the ZT desktop edge for Mac, those are all going to be underpinned by ZT Edge Tunnel. Or you can just run a router. You can actually take, let me go back a build. Hello, back a build. You can just take one of these routers and put it on your host if you want. And you'll see this used a lot with Docker because actually Ken did a great job and discovered this new technique that we did not know about with Docker that allows you to effectively assign one Docker container as the network of another Docker container. And that works really well. And so you can deploy a ZT router into Docker land and then assign your ZT router as the network of another host entity, another Docker container, and effectively kind of emulate Kubernetes pods, which is really, I thought it was fascinating. I think that's really cool. It does require a bit of extra permissions in the Docker world, but it's super neat stuff. If you want to see that, we can get into that too. And of course, taking all of this to its logical final conclusion is don't even trust your host operating system, right? Like bring zero trust all the way into your applications. And this is, I think this is just the absolute pinnacle of where we're heading, where applications that are zero trust enabled are effectively immune to side channel attacks of all flavors. In fact, recently, let's see, not LinkedIn, we'll go to Twitter and we'll go to Ziggy here. Ziggy has recently posted, I think he posted, let's see, profile. How do we get to the profile and posts, reply? Yeah, right here. This right here. This is exactly why application embedded zero trust is so powerful. I don't know if you saw this or not, but this is a whole idea where there's an exploit on browsers that allows them to connect to the local area network. And so people, oftentimes think, well, my application's not going to reach out and talk somewhere, but a browser might do that. Or you never know, your app might have some sort of vulnerability that you just don't know about. If you're allowed to, maybe I'll put this in the show notes as well, but if you're allowed to connect anywhere, then you would be able to perform these sort of side channel attacks. And so when you have application embedded zero trust, the application itself is allowed to talk to whatever server is configured. And why that's so powerful is because if you had a side channel attack like this, there's no way for that application with zero trust baked into it to be compromised from the underlay network or from outside of that process space. You would have to compromise the application itself in order to coerce it to send traffic to the targets that it has access to. You're not able to do those sorts of side channel attacks. Hey, it looks like Ken is watching and has a comment. What is it, Ken? Let's see. I like to put a ZT router in each Compose project. It's a nice way to bootstrap zero trust infrastructure and has lots of uses. That is absolutely true. If you haven't tried to, so Docker gets complicated And I am guilty of creating a complex Docker Compose file that was called the Quick Start, but really it was meant for learning opportunities. And it's confused people before, mostly because, let's see if I can get back to the ask questions. Where is the captions? There it is. Mostly because Docker networking, uh, networking itself is already hard enough for most people. But when you bring Docker networking into that picture, it gets even more complicated. And it comes back up all the time, even on the forums about, I just recently where a person had deployed, in this case, it was ZRock, and they were using ZRock to perform a share. And they had shared localhost colon whatever their port was because it makes sense, right? Like on their local computer, localhost colon 1280 is a routable address and shows up in the browser. So I might as well put that into my ZRock share and then slap it into Docker and everything will be all right. Except, of course, localhost inside of Docker is not the same as localhost on your host network. Unless, of course, you tell the Docker container to use the host operating system's network, and then it becomes the host network again. So it gets really complicated really quickly. But however, like Ken was saying, being able to put into a Docker container into a Docker environment and then use that container for onboarding or offloading, it's much more interesting onboarding and doing the intercepting is just such an interesting and powerful tool. And I was playing around in my off hours with retooling our Docker Compose example because let me flip back over to the old internet and go back to the Docker network local with Compose. Here it is. Because you'll see there's a purple network, a blue network, and a red network. And the reason for this is because of Docker's complexities. Mostly, it is a problem where you can't, you basically, well, at least I never found a way to exclude entities on one network from the other network. It's basically an additive type of thing. So, in order to perform what looks like three different zones here, the purple network, the blue network, and the red network, basically what I have to do is assign this container the blue network, assign this container the blue network and the red network, and this container the red network. And so everything outside of the blue or the red will have both networks assigned to it, allowing whatever's outside of one of the blue or the red networks to be able to communicate with both. And so that can get really complicated really quickly. Oh, we got a question. Love it. Let's see. Question says, where does network resiliency come into the zero trust story? And how does Ziti address that type of use case requirements as well? What a great question. All right, so how does that come in? Let's go back to the presentation because I think this is also on our doc page. PowerPoint, why you got to do me like that? Let's see, we turn off the presentation. Will you go? Why won't you present the slide that I'm trying to present to you? Let's see, you'll close it over here. We'll do this, close that, do this. Then we'll come back over to here. Where do we go? Right here, this slide. Hey, what time it works. All right, so how does network resiliency come into the equation? So I'm gonna have to take your comment down real quick. What you want is an overlay network, which is self-healing. That is the key to resiliency. So here we have 6 routers being displayed. We have 2 in the private data center on the left. We have 2 in the private data center on the right. And we have 2 out on the internet somewhere. Should one of these public routers fail, as you can probably tell, the routers will all have paths that traverse that overlay network. So resiliency becomes important when you have more than one edge router out on the internet that your private routers or private, I mean, it doesn't have to be routers either, by the way, this device over here could also and will also connect to up to 3 routers, at least 3 by default. And so that resiliency is really important. And so when we do a production type deployment, oftentimes we want people to have 2 at least two, so there's one layer of redundancy. It's also true for, say, an attack vector. So like I was saying before, when we have the knock on OpenZiti is, yeah, well, my port used to be open here and used to be in the firewall, and you're just moving that port to this public router, which is somewhat true and also quite a bit not true. But let's just take for granted that we just move the port. We move the port from a firewall somewhere to, say, a router somewhere. That router can certainly have a TCP type of firewall in front of it. It can't be an application firewall because TCP is, well, OpenZiti works on IP. So we don't really inspect anything at the WAF type layer. So if you put an edge router out in the public cloud and you can put a TCP type of firewall in front of that edge router, fantastic. You can go ahead and do that, and then you have additional DDoS protections from whatever nefarious type of activities going on out on the internet. On top of that, you can always spin up multiple edge routers, and the mesh itself will heal itself, and the controller will correctly path your data across that overlay network. On the same, let's see, how does a use case requirement? Yeah, and so optimal routing is also important. So I talked about pathing. One of the things when Michael Quigley was doing some early performance-based testing. I believe he was going from Singapore over in Western Asia to Australia, and was noticing that sometimes the data would actually not go directly from Singapore to Australia or to Sydney. It would go through India once in a while, or Bangladesh, or wherever it was going. But we were shocked to see that it would routinely choose to take a path that was not the direct path, because the overall latency from one router to the other router to the other router was actually much better by avoiding the direct route. And he coined the term, and I love the term, of internet weather. And so when the internet weather would act up, the pathing would shoot from direct, straight, as you would expect, to around the horn. And so that sort of optimal routing is really important. And then load balancing is also vital. So if you have an OpenZiti overlay network, a lot of times people will ask, well, what do I do with my expensive firewalls and my expensive WAFs and all that sort of stuff? Are you telling me I don't need these, and load balancers? Are you telling me I don't need these things? And generally speaking, oftentimes the answer might be no. You don't particularly need them specifically. But I always say you'll always need them, just because another one of my favorite slides is zero trust is a journey, right? And so you are not going to move all your stuff into OpenZiti immediately. And then even after you do, like I was saying, you could still potentially have firewalls and some sort of TCP-based type protections on the ones that you deploy to the edge routers in the sky. Great question. Let's see, what else? Where else was I going here? I was going through. Let's see, we were talking about this. Zeta router in each. Let's see, go back to over here. We were talking about this. We were talking about Docker. Got on a bunch of tangents there. We were talking about this, and the no ports. So let's see, where is this? There it is. No listening ports. And so, and we were taking it to a logical conclusion. That's where we were. Go back to here, and we talk about, because there is one more logical conclusion that comes up in my opinion. And let's see, come back to here, click the button, present, and go to the next one. And that is hardware root of trust. So if you want to use a hardware root of trust. Let's see, do I have one? I do. Let's see, I'll disconnect it. Right? Ever see one of these things? That's a YubiKey right there, and it's a hardware token. You can get these from any vendor. Lots of vendors sell them. And what this will do is it will do the PKI, the cryptographical operations inside of this little device. And so why that's really cool is because then if you want to make sure that nobody can get on your network, you can just take it out, and you can even take it with you. This is so much more powerful than an IP address, right? This whole idea of strong identity, so much more powerful than IP address, and restricting access based on something like IP address. For example, my favorite example of that is I was working on ZSSH, which, if you're not familiar, like I was saying earlier, we'll do a Ziti TV on this quite soon. But ZSSH is basically a SSH over Ziti, but it's a native ZSSH. And I was going to plan to show this today because some of it is relevant. Well, if we got there, but why ZSSH? Why am I bringing it up? Because my favorite example of not using an IP address for the source of access and authorization was I was working with ZSSH, and I had ZSSH'd from my local computer, my laptop, to a machine in the cloud. It was in Amazon, and my son needed to go to the dentist, and so I picked up my laptop and I brought it with me to the dentist. And when I got to the dentist, I opened my laptop and I saw that I was still connected. I had left it on. I didn't want it to close, but it was still connected to the Amazon machine, and I was surprised and I was really blown away because I just expected that I was going to have to go to Amazon's dashboard and whitelist an IP address, but I forgot that I was ZSSH there, and so it was really a mind blowing operation for me where I first really realized how useful that identity idea is, because you can just pick up your laptop and go anywhere, and you don't have to worry about whitelisting IP addresses. And that is such a gigantic superpower of a zero trust overlay network that's based on identities and not IP addresses. Okay. Let's see. I don't know if I think that's. Oh, I was going to go through, maybe show a configuration, maybe show how OpenZiti you can bring up an environment and play with it real quickly. I can go a bunch of different ways, or we can call it a Ziti TV. I don't know what people are thinking. I think that's everything I wanted to go through. Got through it relatively quickly. Let me go back and scan through my. Oh, I know what I was going to show. Yeah, end-to-end encryption. That's also important too. Let's go over to here. Click the button. Click the button. Yeah. So this is also fun. So we're kind of just progressing down the zero trust tunnel here. And now we're getting into this idea of end-to-end encryption, which is also really important. Every good overlay network, especially a zero trust overlay network, must have this end-to-end encryption idea. And what's cool about it is a very common question that we'll get is, if I were to compromise one of your routers, what kind of damage can I cause, right? Will I be able to collect information and see it? Because generally speaking, when you think of TLS, you think of HTTPS, and you think of potentially being attackable. Let's see do I have that? Yeah, here's my little thing. Because when you have a HTTP connection and you wrap it in TLS, you've created HTTPS, which is what we were talking about earlier with that certificate. We talked a little bit about mutual TLS, MTLS, and sometimes people who are a bit less trusting, maybe, will have problems using, say, a public share. So on ZRock, if you were to go to zrock.io, and if you haven't gone there, you should go check it out and get your ZRock account and start sharing things publicly very easily for free. Very generous free tier. But ZRock is a public proxy, a globally distributed reverse proxy back into your home. But it's public, so it allows you to make a share that anybody on the internet can access. Very much not zero trust, but really, really convenient. And so a lot of times when you need to share something really quickly, you'll reach for, email or maybe Signal or something along those lines. Signal also end-to-end encryption. But with ZRock, you can just share a file, you can share a website. So like a lot of times developers, it's really useful. Ryan, a fellow that works with us here, works on the ZD console. Routinely, I'll have a styling problem and I'll say, hey, Ryan, can you help me? And Ryan will be like, sure. Can you send me the URL? And now I can. It used to be I couldn't, but now I just fire up a ZRock public share. I send him the public URL and he accesses my dev machine from wherever. And I'm sure if Ken's watching, he can pump one into the chat real quick, and then you can access it while it's available. I don't know. But the more tinfoil hat among us, they're concerned because even though it's a public endpoint and even though it's encrypted with HTTPS, then it's possible that Zrock could be doing something nefarious and it could be terminating TLS. And it does terminate TLS because it's a public proxy. That's its job. And then it takes that data that it's terminated after it terminates that TLS connection that you made and then shoves it down the pipe and sends it to your local machine. Some people are worried that, well, that means OpenZiti could see, the data that we're sending if we're doing this. And technically, that is true. And so could Cloudflare, and so could Funnels, which is Tailscale. So could Tailscale, or anything that's doing this public proxying for you. Now, realistically, of course, none of those vendors are, because if they get caught, that would be devastating, and it would also be just the wrong thing to do. So we don't, but it's possible. So that's where end-to-end encryption comes in. With end-to-end encryption, you can ensure that even if somebody tried to do something nefarious, it's not even possible. So to go back to this little slide, kind of busy, right? I don't know. What do people think? Is it busy? Is it all right? It's kind of busy because I wanted to show the different connections. You got the green connection down there, which is from one router to another router, mutual TLS. You got the orange connection, which is from that second router to the third router. Then you got the red connection, which is the router to the last router. And then you see that blue pipe that runs all the way through it. That's your end-to-end encrypted tunnel. Only the initiator and only the terminator can see and decrypt that traffic. Boy, plug for Darknet Diaries. I don't know if you have heard of that podcast, but a fantastic Darknet Diary just came out like a couple months ago on Anom, I think, ANOM, which was a chat app built specifically for criminals. And the chat app had end-to-end encryption as well. And the chat app had a secondary target that it would send its data to. So even though end-to-end encryption is fantastic, you still need to be able to have open source software that you can go and check and verify that nothing nefarious is happening, like sending all your data to some big data sink. And so that was a really interesting thing. Go check it out. On top of that, you can ride another encryption if you want. Application connection, the purple box, could have HTTPS on it. So if you wanted to, you could run mutual TLS through that end-to-end encrypted tunnel across those mutual TLS individual connections. And then, you can just turtles all the way down if you want. Let's see, OpenZiti equals software-defined perimeter. Let's see, and then let's pop it up. We got James. Boom. Software-defined perimeter. And then Ken replies, kind of, but SDP feels limiting. Terms was introduced very early in the history of ideas that led to OpenZiti. I don't know enough about the term software-defined perimeter myself to know this answer. I probably should, since I work here, but I don't have a good answer for you. I could Google it real quick, but basically, software-defined perimeter is what it is, right? Like you have a software component that's deployed somewhere and produces that particular perimeter, and you can shrink that perimeter all the way down to the application itself. And so that's, like, to me, that is the end goal. You need to get that zero trust overlay network, all those zero trust principles, into your network. I'm going to actually go and look up what SDP is after this live stream, because I probably should have a much better answer to that than I do. So I'll have to go Google it. Maybe Ken can Google it in the meantime. I don't know. If you have a refining question on that, I can answer it. I just don't know the actual definition of software-defined perimeter with enough specificity to be able to accurately give you a good answer. I'm sorry. Let's see. We got another comment. It seems like Ziti requires strong identity to connect to any endpoint. Does that pose limitations to legacy environments, and how are those addressed? Excellent question. Yes, it absolutely poses a problem. If you require a strong identity and your legacy software does not have that strong identity, you are not connecting. But OpenZiti does have you covered. That goes back to zero trust host access. So I had mentioned before, if you have Windows, you can have this thing right here called the Ziti Desktop Edge for Windows. And if you have a Mac, you can get the Ziti Desktop Edge for Mac. And I put my phone down here so that it wouldn't bother me. If you've got an Android endpoint, you can get the ZT Desktop Edge for mobile, and same for iOS. So, like, basically, there's a Linux one as well called the ZT Edge Tunnel. So all your major operating systems are covered. There might be esoteric ones out there. You might have to build. It's all open source, so you might have to build it yourself. For example, a common thing that gets asked is actually, does OpenZiti support Windows 10? Or XP or whatever. And we've taken the stance that if your operating system is not receiving security updates, just in general, we don't technically support it. But if you can get it to build and get it to run, then great, right? It'll work. So yeah, it is a challenge, but that's where these things called tunnelers come in. Tunnelers are specifically written to provide zero trust host access, this ZTHA stuff. And let's just, we'll leave it, where are we going to leave it? Put it right here, maybe right here, because that's where it is. And that is what lets your legacy software connect to your legacy. Well, not legacy, let's say just non-OpenZiti native applications. So if you are so fortunate as to have application embedded zero trust in your server, then you don't need a tunneler on the server, because the server itself has that zero. It basically has the tunneler or the SDK built into the application. And this is really, like, as I'm a developer, right? So as a developer, to me, this is mind blowing, because too often as a developer, I have to talk to ops people, or if I'm deploying it myself, maybe I'm deploying it myself. But when I deploy locally, it's a little bit different than when I deploy in Docker. It's a little bit different than when I deploy it in Kubernetes. There are all kinds of topology worries I have to worry about. When I have the zero trust principles built into the application itself, I literally just deploy the application anywhere I want in the world. And as long as I have outbound connectivity to a public edge router that can get me onto that overlay network, and when I say public, uh, air-gapped environments. So totally strict, like, actual air-gapped environments are totally reasonable. If you have your own bespoke network that literally is air-gapped, meaning no plug to actual internet, that could be public. It's whatever gets you onto the overlay network. It needs to be addressable from your endpoint. And if you can get onto that overlay network, then you're able to connect to it wherever it's deployed. And that's just an incredible superpower, in my opinion. Let's see, did I miss anything? So tunnelers are your answer to that. And also, tunnelers will support you in zero trust networking access. Remember, even though I scoffed at it, right? Zero trust network access, here it is. Even though I scoffed at it, it's still totally viable. Loads and loads of people still do this right now. And they even send HTTP over their trusted network, right? Because it's all up to you as to what you define as safe enough. And so with a router or ZDH tunnel even, but usually with a router, because ZDH tunnel is usually like, on my device, and ZD router is usually thought of as I'll let you be a router, like other things can connect to it. Both of those can support zero trust network access as well. Another question: How does OpenZiti communicate when the firewall block inbound traffic? Great question. So Ken just offered a comment, which is awesome. Let me go and show the No Open Ports blog that I'm going to put into the show notes if I can find it. Where did it go? No. All right, we'll do No Open Ports OpenZiti blog. I don't remember where it is. There it is. All right. So like Ken was saying, what happens is the server will punch out of the firewall and connect to an edge router in this situation. The same is true for your local computer, right? I hope everybody has a router that denies all inbound traffic at their house. I know I do. But everybody has a firewall, at least on their operating system, that should do the same thing. And so the same was true for your computer. Wherever it might be, it will punch out of whatever hole. And that's why I'm always careful when I say no open ports. I always say you only need outbound connectivity. And so this is not a novel approach at all. The whole idea of a relay server has been around for as long as networking has been a thing. And so that's the way currently OpenZiti works, where we'll have a bunch of routers or one. I mean, unless your router goes down, you're going to be fine. But I run my home network with one router, for example, because it's not mission critical. But you will punch out of your network wherever it is, and you will establish a long-lived TCP connection to that router. And once established, traffic is remarkably fast. I think, even though TCP is quote unquote not as fast as UDP, I mean, I never notice, I never feel it as a human. And even as processes, you never notice or never feel. Once that connection is established, the lines are wide open. Establishing the connection can take a minute, not a minute, but like, a few milliseconds, because there does need to be a communication to the controller. The controller needs to authenticate you, and then it needs to authorize you, and then you need to dial that connection. Let's see, another question. Look at these great questions. How would you compare or differentiate OpenZiti to products like Tailscale or Zero Tier? Also common question, and a source of shame. I've never finished writing these blog posts because I should just be able to point you to them. But Tailscale and OpenZiti, let's start with them real quick. Tailscale built on WireGuard. That's one big difference. WireGuard built on UDP. Currently, OpenZiti is TCP. That has benefits and it has drawbacks. I don't know if you're familiar with UDP and TCP. My favorite networking joke is, networking joke is, I have a UDP joke, but I don't care if you get it, right? Because UDP is lossy. And so if you drop packets, UDP doesn't care. So those are some differences. We had one really interesting revelation where UDP is shockingly easy. I mean, this is not like this is a selling point, but UDP is shockingly easy for firewalls to detect. So we had a person who had gone to a hospital, and the hospital was on a secured network, as you would hope, because it's a hospital. And WireGuard was blocked because it's shockingly easy for them to detect WireGuard. A TCP connection to a server that looks like HTTP, not easy at all. And so OpenZiti worked flawlessly in that environment, whereas WireGuard was blocked. So that's I don't know if it's a selling point, but it's interesting. OpenZiti is also working on UDP based communications. So Paul Lorenz, I know, is working on that. And that has a direct benefit of bypassing that middleman. So a knock, if you could, on OpenZiti is that you have that relay server, and that relay server absolutely does add whatever possible latency might be involved in it. So if you're coming from like your house to your buddy's house and you guys are like right next door to one another, you might have to go to Virginia to come back to wherever you live, And so if you could, it'd be great to just bypass that and go directly there. WireGuard, based on UDP again, it allows you to do that. And WireGuard and UDP has the whole notion of a UDP hole punch, where UDP is also one way. So your router needs to know when you send a message to somebody using UDP, it'll notice that, and it'll allow you to return data back through that port again, which is questionable. I mean, like, it's not worrisome because, obviously WireGuard works flawlessly for tons of people, but there is the possibility that something on the other side could send a packet back through that particular hole. Depending on how big your tinfoil hat is, I don't think it's probably not a big deal, but you may care about something like that. Tailscale is also much more akin to probably the NetFoundry offering as opposed to OpenZiti. When you first fire up Tailscale, you'll notice it's pretty easy. It has a nice cloud console with all kinds of beautiful help. It's got a nice UI, and a lot of engineering has gone into that nice UI. OpenZiti has the ZAC, also a pretty nice UI if you haven't tried the Ziti admin console, but it doesn't have all the nice extra things that an enterprise piece of software can deliver. That's where the NetFoundry console, which is the pay for product that NetFoundry, the company that sponsors the whole project in NetFoundry. They we they we run cloud-based type of thing that gives you the same sort of niceties, and then also a little extras here and there, and then on top of that, support, and so Tailscale will give you those things. And so will Zero Tier. Zero Tier, I'm not as familiar with. I haven't spent much time with them because, frankly, Tailscale and WireGuard, I think, are OpenZiti's by far biggest competitors. Zero Tier is a more of an enterprise type thing. I don't know how pricey it is, but I've never particularly used it. And the sort of stuff that I've seen, if you go look for Philip on Reddit, he's posted some stuff about Zero Tier and probably has a write up. Same sort of question came in from. I hope that helps. Same sort of question about Zscaler. Zscaler, same answer I'll have. I don't know them particularly well. I should have Philip's. Philip's not here, and Redford's not here. But I don't have their like maybe I can go Google it real quick. Let's see if I go to Reddit. Let's see. We go to we'll Reddit. Let's do go to Google instead. We'll do site is reddit.com and OpenZiti versus Zscaler. Let's see. I am sure Philip. Here he is, my buddy Philip. All right. So let's see. This is the old one. Let's see if we have any new ones that are like this. All right. Zscaler. Major differences. Ziti's open source. That's a pretty huge difference, right? Self-hosting is a gigantic difference. Includes SDKs, allow you to be directly embedded, usable for any use case. Yeah, that's true. Sorry, I'm reading this as I go. Zero Tier OpenZiti can be used for any use case, meaning multi-cloud to multi-cloud, IoT. Zero Tier, I think, is where's the Zscaler? This one's Zscaler, I think. Oh, and it looks like Ken has some thoughts. Thanks, Ken. Zero Tier is layer 2, Tailscale is layer 3, OpenZiti is layer 4. Yeah, that's true. Let's see. So if you go out and do that search like I did on Google, you can go and try to read what Philip has said about it. This is something I need to get better at. I just don't have a good talking point for those particular things. All the services are secure remote access. They all vary on their implementations of Zero Trust. They're all, Tailscale I can kind of knock a little bit. It's not entirely open source. Yes, I know there is Headscale. So you can go get Headscale, which is Tailscale does contribute to Headscale. I'm not going to take anything away from Tailscale. I think they're doing great. But open source is probably one of the bigger differences. Self-hosting it, those are some big differences. All right. Wow. Love this engagement. This has been really fun. Are there any, I'm going to pause for a moment. I know it takes probably 10 or 15 seconds for my voice to make it to wherever you might be. If there's any more questions, that's great. If you have, and if there's any that we don't cover here, Ken and I both answer the questions out on Discourse. So you can come out to our openziti.discourse.group and you can ask us questions there. If you have any ideas for future Ziti TVs, anything that's particular that you'd like to see us cover, I enjoy doing this sort of stuff. So if you have something specific, I'm happy to do that. Otherwise, I think I'm going to wrap. So looks like nobody else has any extra questions, which is cool. And then look forward to looking at a Ziti TV that's going to be coming up is that ZSSH with OIDC, and we'll do OIDC exclusive access, which is also a Tailscale type feature, and we'll do OIDC with secondary access, which is neat. So look forward to that.